Howdy, howdy, folks. Once again, it is Donnie, and I am coming at you with another in the series of process management tutorials. And this time, we're going to look at the top utility, and that's something that I promised you 2 videos ago, and I'm finally now doing it. So anyway, the top utility, we just do like that, and this is what we get. And so we have up here at the top of the top, we have the uptime and load averages. And this is the same thing that we get from just doing the uptime command as it showed you in the previous video. And then we have the number of tasks. We have 273 total. We have 1 that's running, 271 that are sleeping, 0 that are stopped, and 0 zombies. And if you want to know what those process states are, if you want to know what they all mean, then you can go back to the video on the PS command, and I explained them there. I don't want to explain them again in this video. Or you can look at the man page for either PS or top, either one. But anyway, we have that, and then down here we have the CPU statistics. And here we have the US. We have 50.4% of our CPU time being taken up by user mode processes, 0.2% of the time being taken up by system mode processes, or you think of it as kernel mode processes if you want to. We have no processes that have been affected by the niceness, although we should, because look here, we have down here in the niceness column, we have one process, the pulse audio, with a niceness value of -11. So I really don't know why that is showing no time there, unless, of course, that is just a sleeping process, okay, because it does show it here as being sleeping. So that could be it. And then we have 49.1% idle time for our CPUs. We have 0.1 wait time for tasks that are waiting to be serviced by the CPU. We have 0.0 hardware interrupt time, 0.0 system interrupt time, and 0.0 time that's being stolen from virtual machines because, well, I don't have any virtual machines running. And of course, if I were to hit the 1 key, we would see all that stuff being broken down per CPU core. And this is the same machine that I have been using for the past couple of videos. It's a Hewlett-Packard, very old Hewlett-Packard from 2009, so it's like 10 years old. And it's running a pair of hexa-core Opteron CPUs. So it's, very old CPUs, but hey, it does the job, does what I need it to do. And you can see here that I have a total of 12 cores, numbered, of course, from 0 through 11. And I can hit the 1 key, and I can just close that down, just go back to the summary of CPUs. And then I have the memory information here, and I have that much memory total. There's 32 gigabyte of memory in that machine, and of course 17 gig free. And then this is the amount used. And we also have this amount in buffer or cache. Now, the one thing here you want to be mindful of is that if this is showing a really, really, really low amount of free memory, you don't necessarily want to be alarmed, because the way Linux works is that when you close down a program, it will keep the code for that program in memory just in case you want to open that program again. It'll make it run a lot faster, or it will make the program open a lot faster the next time that you need to open it. So because of that, you might have a lower amount of free memory showing than what you think that you might need to have showing, right? But the thing is, if you open up another program and that new program needs the memory that is being cached by a previous program, then it'll just go ahead and clear that memory. It'll clear that code from that old previous program out, and you'll still have the memory. So again, just don't be alarmed if this figure is lower than you think it should be. And then we have the swap memory, and looks like we have, what, 32 gig or so of swap memory, and it's all free. I'm not using any swap memory. So it's all available. And then down here, you see here that we have our processes, and we're seeing pretty much the same information that we saw with the PS command. Now, the difference between PS and top is that PS is a static display of what is going on with your system processes, where top, on the other hand, is a dynamic, constantly changing display. So it's like when you use PS, it's like when you take your Brownie Hawkeye camera and load up a roll of Type 620 film and stick in a flash bulb, and you take a snapshot. And once you get the film developed, hey, you have your nice, pretty static picture. But top, on the other hand, is like when you take your Bell & Howell movie camera, you load up a roll of 8mm film, and you wind up the little spring motor, and you shoot a movie. And then when you get your film developed, hey, you got a movie. I know, you all are out there saying, what is this Brownie Hawkeye and Bell & Howell and business? And what's this film business? I know. I am showing my age because those are memories from my childhood. My mom liked her Brownie Hawkeye. My dad liked his Bell & Howell movie camera. But anyway, but no, seriously, the PS, as I said, it's a static display. It's like a snapshot. With top, it's like you're watching a movie. It's constantly changing. So the columns here, they're pretty much the same as you would see if you do a PS AUX command, except some of the names are different. So over here we have the process ID number. Okay, same as we had with PS. And here we have the user. And of course, there's that Donnie character in there and the root user. And here we have the niceness value. The virtual memory, that is the same as the VSZ column in PS. It's just the total amount of memory being used along with virtual memory. The RES is the same as the RSZ in PS. This is the actual amount of memory that is, well, actually, let me rephrase that. That is the actual amount of physical RAM that's being used by a process. And here, the S is the status, and we have the same status codes that we had with PS, with S being sleeping, run is either running or runnable, and we have the percent of CPU time, the percent of memory time, the amount of time that the process has been running, and the command. And we have the SHR. You know what? I got to look and see what the SHR is. But it's all right. We have a man page for that. Okay? So anyway, oh yeah, and also too, let me see if I can get this to work. Yeah, I can. So one idiosyncrasy that we used to have with top is that whatever processes you could see on the screen, that's all you could see, right? You could not scroll down. However, a few years ago, they changed that. So you see now I'm able to scroll all the way down and see the processes that are off the screen. It used to be that if I wanted to see more processes than what fit on just the one screen, I would have to shrink the font size. And I could get it down to microscopic font size, and then I could finally see everything. But nowadays, a couple years ago, as I said, they fixed it so now we can scroll up and down and be able to see all the processes. But anyway, let's go ahead here and hit the Q key And let's look at the top man page. And we see here something that I've just seen today. I've just seen this just now for the first time because I haven't looked at the top man page in ages. So anyway, I just now looked at it, and I saw the first time that there is an actual table of contents for the man page. I've never seen that before. Where has it been all my life? So anyway, so we have the table of contents and gives us a nice overview of what is in the man page. So we do have an explanation of all this stuff here, the overview of the operation, Linux memory types, Linux command line options, or a top command line option, summary display, and the fields, and interactive commands, so on and so forth. So we got a lot of good information here. And you can scroll on down here, and this is another one of those man pages that is extremely well written. If you remember, I told you before about the PS man page, and it is one of the best man pages out there, where the top man pages is right up there with that. Holy cow, look at this. Stupid tricks, sampler, kernel magic, bouncing windows, the big bird window, and the old switcheroo. Holy cow, the people who are writing these man pages have finally grown a sense of humor. That's the first time I've ever noticed that, too. All right, well, you might have to take a look at that here in a few moments. But anyway, I'm sorry, I got distracted. That's the way I am. I get distracted by shiny things. But anyway. Anyway, let's go ahead here. We'll continue this. And we look at the operation there. And operation, we got a few different things there, a few little tricks there that we can do. And basically, we've got different keys there that you can do within top, keep combinations, all that, startup defaults. And I'm not going to sit here and read all this to you. Y'all can come in here to the man page and look at yourselves. And by the way, this is on a Debian system, so Ubuntu should be the same. I haven't checked the other man pages on CentOS or anything like that yet, to see if the top man pages on them have been changed to match this one. But anyway, they should, because the man pages are usually pretty much universal across most distros. But anyway, so we have the Linux memory types, all good stuff there. So as I said, I'll let y'all read about it. I'm not going to take the time now to read it all to you because I don't want to put y'all to sleep. But anyway, we have here the explanation of these different fields that we saw. And so we see here, and this mysterious code that we looked at a moment ago, I didn't know what it was. Well, it's a subset of RES, which excludes 1, includes all 2, 4, and some 3. Okay, what are they talking about? Okay, well, in order to see, we got to come up here to this table, and we have different types of memory. So we have the anonymous memory in the private sector, and a fallback memory in the private sector, and then we have shared memory for both anonymous and fallback. And again, I will let you read the explanation of that and figure it out on your own there. So rather than take the time to explain it here. And we can also look at the rest of these memory codes here, RES and the swap and so forth. And you just go up there to that little table and it will tell you what it's all about. And then we can come down here and we'll look at the command options here in just a moment. Again, it explains here memory usage. Very good thing to read there. And the fields and the columns. And down here we have a more detailed description of the different fields. So CPU usage, memory usage, control group name, C groups, and there are different options, different startup options that we can use in order to get some of these other fields to come up. With just the regular top command without any options, see, you're not going to see the CG name or the C group name, and there might be some other fields there you won't see as well. But again, I'll let you look at the different options in order to see how to do all that. And then we can come down here and let's look at the SHR. Okay, the better explanation here. This is a subset of resident memory that may be used by other processes. So it will include shared anonymous pages and shared file-backed pages. And also includes private pages mapped to files representing program images and shared libraries. Okay, so what we saw up above with that little chart now makes a little bit more sense now that we've seen that. Okay, so anyway, and then we can come down here and lots of other stuff here. And some more keys there, key commands that you can use from within the program. And we will look at some of those here in just a moment. And you can also sort things. You can sort the task window according to different criteria. And by default, the display is sorted according to CPU usage. So whatever is using the most CPU resources comes up at the top. And lots of other good stuff there. And as I say, I'll let y'all go ahead and look at that at your leisure. But anyway, let's look at a couple other tricks here that we can do. Okay, now I did tell you that there are some keys that you can use to do things from within top. For example, you can hit the R key and you can renice a process. And the top process, whatever one is on top, is the default. But let's say that you want to renice something here, like for example, let's say I want to renice, well, the top utility. All right, so let's do 6619 like so. Okay, so that is the PID of the top program. And so now I can enter a value, and this works just like the nice and the renice utilities from the command line. I can lower the process priority with just normal user privileges. So I'll put a +5 in here in this case to lower the process priority. But if I want to raise the process priority, then I would have to use root privileges. Okay, so we see there it is a niceness value of 5. So let's go ahead here and try to put that back to 0. So it's going to be 6619 again. And I want to do 0. Okay, and so yeah, permission denied because I can't do the pseudo privileges from within top. So if I wanted to renice this back to 0, I would have to open up another terminal window and get the process ID number and do sudo with the renice utility. Either that or just shut this down and open it back up again. And then I would be back to the default value of 0. So that's how that works. Also, I can kill a process. I can hit the K command, or the K key rather, and I can also kill a process. And again, I would just enter a process ID number, for the process to kill, and then it would ask me what signal I want to send. Do I want to send a 15 signal, or do I want to send a number 9 signal, for example. So, but anyway, I'm not going to do that. So that's nothing here I want to kill right now. Uh-oh. I did not mean to do that. Well, I just shut down my mining. Oh, do I want to send it? No, I do not. So let's go ahead here and see if hit escape. Okay, good. I did not shut it. Yeah, I mistakenly assumed that by hitting the enter key without entering a process ID number. I forgot about the 2171 process ID being default. So anyway, that's it for, running the different keys. Those are probably the commands you would most run from within top, if you do it from within top at all. And again, you're not going to be able to kill anything that does not belong to you from within top, because you're not going to be able to enter your sudo password from within top. But anyway, here's another little trick. So let's say that we want to have a hard copy display here. Let's do batch mode with the -B, and let's do one iteration here with the -N1, and we're going to redirect this into the top.txt file, like so. And now we can look at top.txt, and there we have it. There we have our entire display. So this is kind of like getting a hard copy display of a PSAUX command, except for the fact we have all that stuff up at the top, which you don't have with PSAUX. And we can come on down, we can scroll on down, and we can see everything, right? So anyway, let's get out of that. Now, let's do something else here. Again, we'll do a -B for batch mode, and this time we'll do a -N5, which means we want 5 iterations of this, and we want them to be 5 seconds apart. And again, I'll just go ahead and redirect the output into the top.txt, which means that I will overwrite what's already there, which is good. That's what I want. So I'm getting 5 iterations of top 5 seconds apart. So this is where we sing anticipation, anticipation. Yes, I feel like I'm selling Heinz ketchup here. Anyway, why would we want to do this? Okay, well, this is kind of like a poor man's way, to get a baseline measurement. So if you want to get a baseline of what's going on with your system, you're not going to do this with just 5 times. You're probably going to do this with enough iterations to last maybe an hour or 2 hours, or maybe just a half hour, just whatever, right? Whatever length of time you want this to go, just adjust the number of iterations accordingly. And that way you have your baseline measurement that you can print out or whatever and just study through. And it gives you a good way to have that baseline so you can see how your system is operating normally. And then if you have any indications later that maybe something might be abnormal, maybe your system isn't working the way or performing in the manner that you think it should, then you pull out that baseline measurement and look to see how things are supposed to be when they're normal and compare it to what you got now. And so that just one of those handy little tricks there that you can try. So anyway, I think that is pretty much it for the top utility. I think I've kind of gone over time in this video, but that's okay. Hopefully I've imparted some good information. So anyway, if you like the video, be sure to like and subscribe and ring that little bell, or click on that little bell icon in the corner if you want to be notified of new videos. And we'll see you next time.